Hello, let's continue our Sudoku adventure with Kreuz by PjoeterBliep. That's German for cross, and as you can see, we do have a cross in the puzzle. All right, well, let's go over the rules. We have normal 6x6 Sudoku rules, so in each row, each column, and each 2x3 box, we're placing the digits 1 to 6 exactly once each. You can see that PjoeterBliep has rotated the puzzle 90 degrees, so the cross is upright. But you know, if you imagine you were to print this on paper, you could rotate it. So it's the same boxes you're used to, just in a different orientation. All right. We also have German whisper lines in the grid. That's this line here, and then also this is a loop, but also counts as a line. Any two adjacent digits on the line have to have a difference of at least 5. So if this was 2, this would have to be 5 or 6. Sorry, difference of at least 3. I said 5. 5 is the 9x9. In 6x6, we make it a difference of 3. So this would have to be 5 or 6, because any other digit, like a 4, if you do 4 minus 2, that's a difference of 2. That's not at least 3. You learn something every day. So this could be 5 or 6, but also over here, this is next to the 2. So this would also have to be a 5 or a 6. All right, and we also have this singular black dot down here. Digits separated by a black dot have a 1 to 2 ratio, meaning 1 is double the other. So if this was a 2, this could be 1, because 2 is double 1, or this could be 4, because 4 is double 2. So you can see order doesn't matter. Just one of the digits is exactly double the other. Not all the black dots are given. This black dot just tells us about these two cells. It's not telling us about any other cells in the grid. If I have 2, 4 here, there could have been a black dot. There's not. That's perfectly fine. All right. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right. I do think we need to color to start. So the property of German whispers is they always alternate low-high. We pick that difference digit for the size of the grid very specifically, so that you're forced to go low, high, low, high, low, high. So for example, if this was a low digit, a 1, 2, 3, from that 1, 2, 3, in order to have a difference of 3, we have to go up into the 4, 5, 6 range. And then once you're in 4, 5, 6 range, you have to get back down to the 1, 2, 3 range. Otherwise, you won't have a difference of 3 or more. Now, we don't know which is low or high, but whatever this is, we're going to call green. Whatever this is, we're going to call purple. Since they're next to each other, we know one of them will be low and the other will be high. And we can just continue alternating down the line to give us all these colors. Now it looks like these two columns can be finished, and that's going to tell us the colors of these lines as connected to this line, which is very nice. So the reason we can finish is we know that there's 3 lows and 3 highs in every row, column, and box. So there's 3 greens and 3 purples. Well, we already have our 3 greens. We need our last purple, and then we need our last green. So now this is going to alternate. Oops. Purple, purple, and green, purple, green. Right. So obviously from here, we don't even have any digits. We just have colors. I don't think there's any way to continue the colors. I'm just going to make sure to look at every row and column. But yeah, there isn't really a good way to continue the colors from here. So we probably need to think about 3s and 4s. So the other big thing about German whispers to remember is that 3 and 4 are very special. This is the 6x6 German whisper thing. In 9x9, in like an odd size grid, there's actually one digit that's completely banned. So like in a 9x9 with a difference of 5, you can't put a 5 anywhere. The kind of equivalent of that in 6x6 is that 3 and 4 are quite restricted. In that if this was a 3, and actually with 4, it's the same as 4-6 in a 5. Anyway, if you're used to 9x9 German whispers, it's the same as 4-6. There's no band digit though. So if this was 3, let's just from the start, if this digit were 3, we would break the puzzle because 3 has only one buddy. 3 can only go with 6. If we want a difference of 3 from 3, you can only put 6. This is perfectly fine. But now look at this pair here. This is also next to a 3, the same 3. So it also has to be a 6. And now we have put 2 6s in this box. So generically, any cell where its 2 neighbors share the same row, column, or box, or for some other reason can't repeat, we're not allowed to put a 3 or a 4 there. 4 can only go with 1. And so this is not a 3, 4. So I'm going to mark that as 1, 2, 5, 6. And we're just going to go down this entire loop and look for any others that have that same property. So this can only be 1, 2, 5, 6 because it's vertical. This can only be 1, 2, 5, 6. So can this, and so can this. That makes this a 3, 4 pair. I'm going to do something with the 3, 4 in a second, but I'm going to just keep going down the line to make sure I didn't miss any. This one here is 1, 2, 5, 6. But we know these are the 3, 4s anyway. So yeah, those would have come from that. But anyway, okay, so remember what's special about 3 or 4? We can only put 1 next to the 4 and 6 next to the 3. So these cannot be 2 5s. And these are also 1 6. So what we've done here is, you can think about this 1 6 pair. We move 1 6 from here. We have a 1 3 4 6 triple or quadruple here, leaving 2 5 for the row. You can think about it that way, but you can also individually think about these, because we don't know if green is low or high. But if green is low, this is a 2. If green is high, this is a 5, right? Green is going to be 1 2 3 or 4 5 6. There's kind of this symmetric relationship where this is the 2 5 flavor of green, which is a singular flavor of green. There are 3 flavors of green: the 1 6, the 2 5, and the 3 4. And they're the same 3 flavors of purple: the 1 6, the 2 5, and the 3 4. And they're just the opposite of each other. So the fact that I already have my 2 5 flavor and my 3 4 flavor leaves just the 1 6 flavor here for green. And then for purple, we only have the 1 6 flavor here, right? So we can treat these as if they were individual digits and eliminate only from the same color, though. So like this here cannot be a green 1 6. So it has to be from 2 3 4 5, for example. These cannot be the green 1 6. So they're from 2 3 4 5. Can I continue this? Purple's probably, yeah, these can't be the purple 1 6. So these are from 2 3 4 5. But you could also have just seen the 1 6 pair in the box. But I'm trying to demonstrate this. So this sees the purple 1 6. So it's from 2 3 4 5. Also sees the 1 6 pair, right? All right. Anything else here? Did I get any more? Oh, you know what? Stuff like this is interesting now, because this cannot be the 3 4 anymore, because it needs to be surrounded by 1 6s, and we know this isn't the 1 6. So this cannot be the 3 4, leaving 1 2 5 6. There's probably more like that. Yeah, so anything next to these 2 3 4 5s cannot be 3 4. Right, so this can't be 3 4 because it's not next to a 1 6. And this can't be 3 4 because it's not next to 1 6. So that 2 5 eliminates 2 5 from here. This 3 4 makes this have to be 1 6. There's probably more like that. This can't be a 3 4 anymore. And it can't be 1 6. So if it's not 3 4 1 6, it's 2 5, meaning this is a 3 4 surrounded by 1 6s. This entire pattern is symmetric, so we should expect the exact same deduction in green. If we find a deduction green, we should be able to find the exact same deduction in purple, and vice versa. So this isn't 3 4, right? It's 2 5, and then this is 2 5. In fact, you could split the whole puzzle down the middle and reflect it, and just, if you get a digit over here, you're going to get the equivalent digit over here in the other color. This black dot is what disrupts the symmetry. In fact, looking at this black dot, it sees a 2 5 pair. Now, we already couldn't put a 5 on a black dot. If you try to put a 5 on a black dot, the other digit would have to be 2.5 or 10. Good luck. But we also can't put a 2 on here. And there's actually just 2 groups in 6 by 6. There's 2 groups that can go on a black dot. There's the 1 2 4 group, where you're using a 2 for sure, and it goes with 1 or 4. And there's the 3 6 group. Well, we can't do the 1 2 4 group because of the 2 5 pair here, removing 2. And 1 and 4 are not, one's not double the other, it's 4 times the other. So we need to do the 3 6 group here, and that tells us that green is low. So for every single green, I can just replace it with its low digit. 1 2 1 3 2 2, and then every purple digit you replace with the high digit. 4 5 6 5 6 5 4 6 5 6 5. That's 3 6. I'm going to get rid of the colors so I don't have to continue them. And I should just be Sudoku from here. So this is 1 and 4, finished with a 3. So if we wanted to use the symmetry here, equivalent to 3 is what? So 4, right? I don't know if the symmetry continues with this black dot here, but anyway. So let's not do it that way. But anyway, that's a 3. And then 1 2 3. This is 4 6. So that's 4 6. I think it must continue, wasn't it? I'm not sure if it can. It had to be in this parts of the clues that were symmetric, but I'm not convinced it has to be true for the ones that aren't part of these clues. But I don't know, maybe. I haven't thought about it hard enough. This is 1 4. So 4 and 1. Over here we need 3 5. That's 3 5. And then over here we need a 2 and a 4. So did we end up symmetric? Yeah, 3 4 1 6 3 4 2 5 3 4 1 6 3 4. Yeah. So it is fully symmetric down the middle. I think it only had to be that way if these German whispers create a unique solution other than swapping low-high. If that were true, then the solution will be symmetric because there's only two solutions. So yeah, if we have only two solutions with just the green lines, then adding this dot just tells you which solution to use because you can't make it 1-4, so it has to be 1-3-6. But if it were not unique, like if there were more than two solutions here, then one of them might not be symmetric and you could choose that one. I think that would be true. Okay. Anyway, someone might be able to discover whether that's true or not. All right. Well, let me know how you did. If you enjoyed this, why don't leave a like, subscribe, and a kind comment below.